So next up, we have Jochen Appel, Vice President and Tribe Leader, Fixed and Mobile Data Platforms with Deutsche Telekom. Jochen leads the development of Deutsche Telekom's Access 4.0 software-defined gigabit access network, as well as DT's mobile core efforts. So we'll try to share your questions with Jochen after his talk, so please do send them in. And with that, Jochen, welcome, and please take it away.
Thanks, Timon. So welcome, everyone. Pleasure to be with you today. First of all, I hope that you and your families are healthy and safe at home or wherever you are at the moment. And so yes, as Sim already mentioned, those are quite challenging times for all of us, but I'm sure something we will also jointly overcome. At the same time, I think it's very exciting times for ONF activities for the reasons as Sim already mentioned in his presentation. We are approaching first live deployments of SIBA Volte. Robert and I will talk about that today. And it's also encouraging to see that as far as the roadmap is concerned, so this pandemic, I don't think it's slowing us down in any way. I personally experience quite the opposite, especially if I look into my team. It increases the motivation of everyone on my team for transforming the networks, the production models into this global network as a services platform, that flexible modular platform even faster, leveraging the paradigms of the hyperscaler world. So, but I will come to this, we will come to that in a few minutes. So a few words about myself. As Timon and Asim already mentioned, my name is Jochen Appel. I'm with Deutsche Telekom. There, I'm the program sponsor for Access 4.0, which is our Deutsche Telekom implementation of SIBA Volte here in Germany. And today I want to talk about three things. First, I want to give you more context in which Access 4.0 is a part of, namely our transformation strategy towards a software-defined telco. And second, we will have a closer look into Access 4.0. I will briefly touch on that, give you a high-level overview. Robert will talk more about Access 4.0 in more detail later in his presentation. And I also want to finally, I want to briefly show you the immediate next steps we take as Deutsche Telekom to make this first disaggregated production model proof point successful. Some of you are already familiar with that presentation, which I gave probably half a year ago at ONF in Santa Clara. Well, that doesn't mean we don't have anything new to tell you, but it basically means that we continue with our strategy, yeah, which should be quite stable and should not change that often. So I think what is shown here is, again, what I said last time, which is a continuation of a big success story, which is the transformative, in essence, the transformative power of open innovation and ecosystems. We all know what has started in the late 90s with Linux and the classical IT stack. That has finally arrived for the telco network technology stack. And what has accomplished in IT 2 decades ago we see now here. And I don't need to explain you all the details of disaggregated solutions, disaggregated technology components, and the change from monolithic systems to best-in-class modular functional software components. What I want to point out here more is what refers more to what I would call the big picture, the cultural change we also have in the organizational change. So while new technology and new capabilities are an important enabler, so if you look at that point here, waterfall style engineering versus DevOps, I think that is a much larger thing we have to accomplish here. We have to accomplish a cultural change, develop new skills, and find the right organization models which are required as well for this change to happen. So all too often, I think we experience with new technology, if we just focus on that, we fall into the trap of rebuilding old paradigms and processes just with new technology. So if we don't pay attention here as organizations who employ these new technologies, we will get these fancy new technologies, but we will also have them manifested in new silos called AKA the virtual silos, we call them. And thereby foregoing also the transformative capabilities of those new technologies. And to accommodate for this bigger transformation, we at Telekom Deutschland, in our technology organization, we gave ourselves roughly a year ago a new organizational structure where we are bringing together previously separated entities from engineering, planning, and operations into DevOps teams with end-to-end responsibility for their respective network services domain. At the same time, we drive disaggregation of the classical technology silos into separate infrastructure and service functions domains. But we shouldn't ignore that on the technology side, of course, we have still some important obstacles to overcome when we talk about network disaggregation. So coming back to that, with network services specifically, as you know, we still face many dependencies between hardware and the software layer. Especially this is prevalent to the experts here and around who are developing or familiar with data path elements and so-called middle boxes involved in network policy enforcement. So we see a lot of dependency of higher layer network services from capabilities of the underlying hardware. And specifically the silicon in the data path, which is often the reason why service introduction times take significantly longer than service introduction times in classical IT. So at Deutsche Telekom, this transformation towards software-driven network services happens simultaneously across all layers of our architecture. I just want to give here a high-level overview on the design principles we have. As said before, we consider disaggregation and softwarization as the two major technological foundations of this transformation. But the next thing I have here is the so-called separation of concerns paradigm. What do I mean by that? Well, very simple. It means that from a perspective of a higher layer service, one must not deal with implementation specifics or specifics of the implementation of the components out of which those services are composed. Or more abstract, it means, well, abstracting away vendor specifics of technologies and configuration data from the business layers above. Hiding the network technologies and using APIs between the application ITs and the network. And for us, the benefit of that would be obviously to that the BSS OSS systems will no longer be tightly integrated with our network technology, which then brings at the end, hopefully, significant benefits for changeability of the network. I would even say that changeability of these network components is the major benefit of the entire exercise we are doing here in Access 4.0. The next thing is effective end-to-end service orchestration. So Access 4.0 is specifically dealing with the access domain. Nonetheless, let's not forget that for services such as software-defined SD-WAN, software-defined wide area networking for corporate customers, for instance, it's clear that such a multi-domain service needs an effective end-to-end orchestration. And here it's also obvious that the component in the chain which requires the longest time to develop will ultimately determine the entire time to market for the end-to-end service. And once in operation, the slowest process component in the change will impact service activation for new subscribers, or turn up of new locations, or introduction of new service variants. So of course, the key question is how can we eliminate manual processes along the entire end-to-end process chain? This requires these effective end-to-end orchestration capabilities, which spans multiple domains. Some of which are not, most of which, in fact, in global services are not under your control with the specific implementation details in that domain. And finally, open APIs and ecosystems, where we would use standard descriptions for network services, allowing external partners to develop and market global connectivity products on top of our network services. For instance, if you look at Mobile EdgeX, which Deutsche Telekom funded, this is one such an example of a developer ecosystem and a platform with the ambition for global cross-operator reach, which gives developers access to global cellular infrastructure for mobile edge applications, requiring low latency, location, user authentication, etc. As Deutsche Telekom, we are engaged and committed to the industry communities who drive this change. We believe this requires a very good coordination and collaboration to avoid also duplication of efforts and also confusion. So I experience a lot of similar activities going on in similar bodies or bodies with a lot of overlap. And we are currently looking into how can we actually jointly with the community define centers of gravity for innovation and standards in those respective areas. And also, I think we need to strive for a balance between innovation, open innovation, and standardization. So we face a classical dilemma here. So I strongly believe innovation emerges through competition, whereas a rigid and overly formal standardization will cause a lot of inertia. So to solve this dilemma, we take a more pragmatic implementation-oriented approach towards standardization by seeking and co-developing communities of like-minded partners willing to jointly drive and develop the intended implementations together. Thereby using technologies of those partners, of any partners at the table, and then attracting additional partners and also customers, of course, for those partner suppliers we have at the table. So if you ask me, did this approach of open innovation, ONF, pay off for you? Did it give you what you were looking for? Well, as I said in the beginning, we are approaching a very important proof point. So up till now, yes, I really believe, and I'm excited that the involvement with ONF and the partners here produced first concrete results for us. So for instance, Access for Zero, our DT implementation of CBA Volti under the lead of Robert. We will hear more about that in a few minutes. And also, I should not forget about the open source EPC activity, COMEC architecture implementation, also developed together with ONF ecosystem partners under the lead of my colleague Mika Severa at T-Mobile Poland. So I'm really proud of what we accomplished in the last 2 years in ONF and with our partners. And so my team and I, we are really committed to take that to the next step, which ultimately would mean go live of that in a live network quite soon. So let's have a closer look at Access 4.0, still a high-level overview. So this was born a couple of years ago as part of a program in which we're aiming to reduce the unit cost or improve the cost performance, if you will, for our broadband access. So first, we are solely focusing on the unit cost, but then in order to come up with a step change, we decided to radically rethink the way we produce this gigabit access technology in Germany and started to investigate the CORD principles, the central office architected as a data center principles, to incorporate in the new architecture. So this new architecture Robert and team are developing under Access for Zero, we based on OCP compliant white box hardware and ONF based Volta software stack components. But equally important for us is that this architecture includes and makes use from the beginning of maximum end-to-end automation, right from the beginning. So our aim was also to make the financial case work with the first tenant. As you know, in cloud deployments, very often, the very first deployments have to basically pay for the majority of the setup cost of your infrastructure. And so we wanted to make this work with the first tenant application, which will be FTTH. However, we do anticipate convergence of those today separate streams of fixed access and mobile access into a common edge architecture in the near future, especially if we are considering 5G deployments as we speak. So therefore, the platform has to be open in such a way to make it easily expandable for future edge functions and fixed mobile convergence scenarios. So how does the high-level roadmap look like? So based on our first prototypes for Volta, BNG, and MCORD back in 2018, now in the year 2020, we are now reaching the critical inflection point to bring those first deployments of Volta SEBA, including the BNG and service edge live. We are also looking into converged architectures and we are prototyping heavily in already in common user plane function infrastructure. But the focus this year, I would say, is pretty much on the Volta SEBA go live. because we feel without having this first live network experience and all the challenges we would face there, you know, I'm fearing a bit we are overlooking a lot of specifics, and the learnings we need to have from a live deployment, we need to incorporate to make the next version better. So, but once we are successful with this plan, we want to quickly learn and scale that out, beginning the next year, over the next 2 years, and as we move forward, also prepare the mentioned conversion scenarios. Yeah, with first converged user plane functions, first in prototype and test deployments, first trials in 2021. And then if we go towards 2022, we might see also a convergence of first 5G core applications on A4 edge cloud deployments. So how does the journey continue? What runs well already? What has been accomplished already? And what comes next, and what do we ask our industry partners for? So we think, and as I said in the beginning, I think we are seeing continued high momentum in the industry of all of our industry partners. Everybody is committed in making this year SIBA VoLTE happen. We want to prove that and have that as a major reference to show the industry disaggregated models work in the live network and not just in the lab, and not just in small trials, but in real life net deployments. So after the search is successfully completed, we then also have to integrate that now into an open automation test platform. I was speaking about the ambition to do full automation from the beginning. So here, a lot of things have happened, but we are not yet at the end. So we are continuing at a good progress that has already been shown here. What is also important is, and what I like a lot, is that a lot of folks from our partners and in the community are increasingly looking into maturing the OSNR operation support. Also with regards to the mentioned automation cases we have, but that is really something we need to focus more on, I feel, also in the future, because as I said, a lot of focus is on technology, and although this is technology, I think the support technology for operations processes, for automation processes is as important to avoid building new technology fit for old processes and old support systems. So scale up, as I said, is a very important next step. The VoLTE, to make sure we get VoLTE long-term support from the industry and ONF available. And we also look continuously to integrate further suppliers and products into the community and to certify them for our solution. With SIBA 2.0, we integrate BNG, G.fast, and millimeter wave wavelengths access into this access portfolio. And for the converged fixed mobile support, as I said, we are aiming for COMAC demos, prototypes, to maybe have something live in the next 2 years also in the network with regards to 5G A4 convergence. So with that, I am closing my my presentation. I would like to hand over to Robert, who will explain you more about the details of the Access 4.0 program, where we stand, and how we take it from there into the next steps.